Hello there guys, welcome back to another epic inexorable maths video. In this video we're looking at logarithmic differentiation. So this is a kind of strategy for differentiating functions where we take natural logarithms on both sides. And I mean, we're going to do the first question in a second. You can already potentially see that taking logarithms of both sides of this could be rather fruitful, because otherwise it's pretty difficult looking to differentiate, right? Because you have an x in the base and there's a function of x in the power as well. That's very difficult. So prerequisites to this video, you just need to know about implicit differentiation. My video on that will be in the link in the description. And also, not necessarily essential, but I also have a video on differentiating functions of the form f of x to the power of g of x, which is basically what we're doing. So I've pretty much already got a video on logarithmic differentiation, but I want to do more examples right here. Links to both of those in the description. As long as you know how to do implicit differentiation, we're all good. So let's dive straight into the first of two questions. So the first idea is we are going to take logarithms on both sides of this equation. So we're going to start off with y equals x to the power of x plus 1, like this. That implies that the natural log of y is the natural log of x to the power of x plus 1. Then we can use rules of logarithms to simplify the right-hand side. We can bring the x plus 1 down and have it multiplying by the natural log using that logarithm rule. So we have the x plus 1 is going to be here, and this is going to be multiplied by just the natural log of x without the power, okay? Now, this maybe seems like it's kind of okay. Okay, the natural log of y is a little bit scandalous, potentially, but we know how to use implicit differentiation. On the right-hand side, this is basically just a product rule. So you can directly do the product rule with this, or you could expand it out slightly, which I will do. So this is going to give us on the right-hand side x times the natural log of x plus 1 times the natural log of x. Maybe that's a little bit easier to deal with than x plus 1 times the natural log of x. It's completely your preference. Then we're going to differentiate both sides with respect to x. Now, the natural log of y with respect to x is going to differentiate to 1 over y times dy dx, okay? The reason, if you know about implicit differentiation, is because, and I'm going to write this down, this is implicit differentiation over here, okay? This is really important. The derivative with respect to x of a function of y, okay, a function of y, okay, is the derivative with respect to y of that function times dy dx. This is literally just implicit differentiation. So for example, if I was to differentiate, let's say y squared with respect to x, this would be 2y times dy dx, like for example. Okay, so if I differentiate the natural log of y with respect to x, I'm going to get the derivative of the natural log of y with respect to y, which is 1 over y, okay, because the natural log of x differentiates to 1 over x. And then I have to multiply it by dy dx. It's just implicit differentiation. And if you're wondering why this is even true, I also have a video on that, as I said, and it basically just comes from the chain rule, but that gets explained in the implicit differentiation video. So for now, I'm assuming that you're pretty happy with this idea. And then we're going to differentiate the right-hand side, which is x ln x plus ln x. So x ln x needs to be differentiated with the product rule. So let's differentiate x and leave the natural log of x how it is. So that will just be the natural log of x. Then let's leave x and differentiate the natural log of x. The natural log of x again differentiates to 1 over x. So we have x times 1 over x, which is just the number 1. Okay, then we need to differentiate the natural log of x all on its own, which is just 1 over x. That's not part of the product rule, that's just another term. Now we have this. Now, in order to get dy dx on its own, we should multiply both sides by y. So I'm just going to move the board upwards slightly. And multiplying both sides by y, we have dy dx is equal to y times the natural log of x plus 1 over x, all in brackets there, like that. And finally, we know what y is. Y is x to the power of x plus 1. So we're going to replace that. We're going to replace y with x to the power of x plus 1. So we have x to the power of x plus 1, that's just y, times ln x plus 1 over x. And that is fine to leave as the final answer. If you like, you could potentially simplify this by multiplying the inside of these brackets by x and then dividing this term by x, so it's all the same. And that would be maybe quite nice because you can have x to the power of x on the outside, and on the inside you have x ln x plus 1, which is, that's quite nice. That's quite nice. So that's also another way of writing the answer. So hopefully, guys, hopefully that makes sense and you're all happy with that. On to the second question. All right, so the next question is right there, y equals 1 minus x squared divided by the square root of 1 plus 2x. You might say, well, hold on a moment. I don't even need logarithms to do that. Why do I need a logarithm? I can just use a little bit of chain rule. I can use a little bit of quotient rule because it's a fraction. The chain rule is needed for the denominator, right? And then I'm going to be done. And you're absolutely right. You can do that. You can. It's fine. You don't need to do what I'm about to show you. But I'm going to make the case that it's just as fast, or maybe even faster, to do this rather than go into the entire, I'm going to use the quotient rule, I'm going to use the chain rule. Because what you'll see is that this becomes very simple when you take logarithms, because fractions turn into differences. They turn into basically just adding and taking things away. Powers can come down when you have logarithms, and you're going to see this becomes pretty nice. So let's just do it anyway, guys. Humor me for a moment. So I'm going to, and of course we want to, the question is find dy dx, of course. So I'm going to take logarithms on both sides. So the natural log of y is the natural log of 1 minus x squared over the square root of 1 plus 2x, like this. And then I'm going to use rules of logarithms to rewrite this as the difference between two logarithms. So I'm going to write this as the natural log of 1 minus x squared minus the natural log of the square root of 1 plus 2x. Okay, this is a logarithm rule. The natural log, or any logarithm of a over b, is the logarithm of a minus the logarithm of b. Okay, so it was just a normal logarithm rule. Then we can simplify this one slightly. So the natural log of y is going to be still the natural log of 1 minus x squared minus, and because remember the square root of a function is the same thing as raising it to the power of a half. So this is like 1 plus 2x to the power of a half. It's the same thing. And then I can float the 1/2 down, and I can go 1/2 times the natural log of just 1 plus 2x. And now guys, look at what we have here. These functions, as long as you're happy with differentiating logarithms, these are pretty easy to differentiate. There's no quotient rule at all. There's no chain rule. Well, I guess the logarithm is still a chain rule, but it's easy. It's by the book. There's a nice way of doing the derivative of the natural log. So let's just go ahead and differentiate both sides with respect to x. Again, the natural log of y is going to be 1 over y dy dx, just like in the first question. And on the right-hand side, we need to differentiate these logarithms. Now remember, I'm going to write this down. Okay, if y is the natural log of a function of x, like this, that means that dy dx is the derivative of the function divided by the function. This is a standard formula. This also comes from the chain rule, okay? So we're going to use this over and over and over again. Hopefully you're at least implicitly, no pun intended, familiar with that idea. When you differentiate a function, you kind of do this thing. So this first logarithm is going to be minus 2x over 1 minus x squared, okay? Because the derivative of 1 minus x squared is minus 2x. And then we divide by the original function. And then here I'm going to put the half, and then I'm going to differentiate the natural log of 1 plus 2x. The derivative of 1 plus 2x is 2. So it's going to be 2 over 1 plus 2x, like that. Okay? Right, we can clean this up slightly. I'm going to times those sides by y and also these 2's can kind of cancel out here as well. So I'm going to end up with, moving the board upwards again, I'm going to end up with dy dx is equal to y times minus 2x over 1 minus x squared minus, and then the 2's have cancelled out, so it's just minus 1 over 1 plus 2x, like that. And once again, we need to replace y with the original definition of it, which is this here. So the derivative of this function, okay, is just going to be 1 minus x squared over the square root of 1 plus 2x, because that's the original function y, in brackets, multiplied by this, which is minus 2x over 1 minus x squared minus 1 over 1 plus 2x. And of course, this can be simplified in several different ways. Notice the 1 minus x squared and the 1 minus x squared would cancel out if you distributed this. You could write it in some form where the denominator is 1 plus 2x to the power of 3 over 2 if you wanted to, but I'm not too concerned with simplifying it. What I'll do is I'll simplify it in a cut, and then you can see what it simplifies to right now. Okay guys, so I've just done the working out for us, and so what we end up getting is dy dx is this, and I'm just going to move the board up slightly. I don't know if you can see the bottom or not, but you end up getting that if you simplify it as nicely as possible, in my opinion, it will be minus 1 plus 2x plus 3x squared divided by 1 plus 2x to the power of 3 over 2. That's probably the nicest way of writing it. So hopefully that's helpful. More logarithmic differentiation videos coming at you in the future. As always, guys, thank you so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.